Now, just taking a look at a couple more examples of adding and subtracting polynomials. I'm going to use a line method on each one of these, or the horizontal method. If you use the vertical or column method, that's fine. I'm just not going to show both ways each time. Adding should be a little bit easier than subtracting, because when you get rid of the parentheses, nothing changes. Or you could even add the two polynomials together without technically getting rid of the parentheses. So on number 15, this polynomial is already in standard form. So is this. Just as a quick refresher, each of those polynomials have three terms in them, x squared plus 3x plus 5. So that's a trinomial. So it's a negative x squared plus 6x minus 4. This first trinomial, the degree is 2. The leading coefficient is 1. Degree is 2 here. Leading coefficient is actually negative 1. Okay, so the first thing that we can do is add that x squared and negative x squared. Those actually cancel each other out. I'm not even going to write 0x squared. X squared minus x squared, those cancel each other out. 3x plus 6x are like terms as well. 3x plus 6x is 9x. I'm done with those. I cross these out as well. And then positive 5 plus negative 4, it's the same as 5 minus 4 minus 1. Just because we're adding two trinomials together, it doesn't necessarily we're going to end up with a trinomial. Okay, we added the two trinomials together, we end up with a binomial. So kind of anything's possible. Right. And then what I'm going to go to next is number 18. So in this case, we're finding the difference, which is subtracting. So I'm going to subtract these two polynomials. Again, remember, you're subtracting the entire second polynomial from the first polynomial, so you need to distribute the negative or distribute the negative 1. So the first polynomial stays exactly the same, negative 5h minus 2. And then a negative times 7h is negative 7h. Negative times positive 6 is a negative 6. Now we can combine the like terms. Negative 5h and negative 7h are like terms. Make sure that you have the signs along with each of the terms. So negative 5 minus 7 is negative 12h. We're done with those two terms. And then negative 2 minus 6, those are like terms. So negative 2 minus 6, negative 8. And just to double check, this is in standard form. Okay. Take a minute, maybe try to work through number 20, pause the video, and then see if you can come up with a correct solution. Okay, on number 20, just like on number 18, you want to distribute the negative. So I'm going to keep the first polynomial exactly the same, k squared plus 6k cubed minus 4 minus 5k cubed minus 7k, and then plus 3k squared. Because each of the terms of the second polynomial change signs when you distribute the negative. Okay, here's what I'm going to do. I recognize that k to the third power is the largest exponent. So instead of starting with k squared, even though the 3k squared is a like term, I'm going to plan ahead to make sure that my polynomial is in standard form. 6k cubed, and then a like term with that is negative 5k cubed. 6 minus 5 is 1. I could either write it as k cubed or 1k cubed. It really doesn't matter. But we're done with those terms. The next term should be the k squared term, because we were writing the exponents of the variable from largest to smallest, or it's also called in descending order. So k squared plus 3k squared. This is 1k squared, even though a number is not written in front of it. But 1k squared plus 3k squared is 4k squared. We're done with those terms, so I'm going to cross them out. There's a standalone term. There's actually a couple of standalone terms. Negative 7k. There's no like term with that, but that's really what should come next, because that's the next variable, next highest, or next lowest, if you want to think about it that way, variable's exponent. So negative 7k, there's no like terms with that. It just stays the same. And then lastly, minus 4 or negative 4, that's a standalone term as well. There's no like term with that. So after you subtract, that's what you should end up with. That's in standard form. You have a polynomial with 4 terms. The degree is 3, and then the leading coefficient is 1.